topic is electron gain enthalpy or electron affinity of the periodic properties of the elements. So in this we will say what is meaning of electron gain enthalpy and electron affinity. Electron gain enthalpy means gain of energy, okay, through the electron. So how we are gaining electron energy through the electron? You can see delta H Eg is the electron gain enthalpy, is defined as enthalpy change during the process of isolated gaseous atom. Means if a atom is in gaseous state and during the formation of gaseous state, so whatever the during the process of isolated gas atom or ion, so whatever the change in enthalpy is called as electron gain enthalpy, and this is basically done by the electron. So how electron change the enthalpy? You can see this is any X atom. This is any X atom, okay. So this X atom is in gaseous state. So first we write this X atom is in gaseous state. So when you add one electron, so it becomes X negative. So this is also in gaseous state. So you will get some energy that is called delta H Eg or delta E Eg. Whatever you write, the same E or H. And here again, if you add one more electrons, it will be again in gaseous state. So it becomes so 2 negative charge after gaining electrons. So there is second energy. And again, if you add electron, it becomes X3. This is also in gaseous state. So this will become third energy, delta Eg2. So delta Eg1, 2, and this will be 3. So there are 3 energy will be there. So total energy, how much is so released by this one, released or gained by this element X in a gaseous state. So delta H Eg is equal to delta H Eg1, Eg2 and Eg3. Okay, in which delta Eg3 is greater than Eg2 so and Eg3. Why this is greater? Why this is lesser? So but this energy will be negative. Negative means this energy has been released, but in these cases the energy is not released, this energy is absorbed. Means this, in these two cases energy is absorbed, and in this case energy is released. Means this energy is exothermic and this energy is endothermic. Endothermic means energy is absorbed by anion X minus or X2 minus to formation of X3 minus. So here energy has been absorbed, here energy is released. Now why here energy is released and why here energy is absorbed? So reason is there. So why this is positive energy? Because energy is required to add electron in an atom, and energy is needed to overpower the repulsive force between negatively charged particles, negatively charged spheres and the less electron. Why? See here, if you add electron in this end, what happens? Already this charge is negative, so on adding electron there will be repulsive forces. That's why it has repulsive forces. To overpower that repulsive forces, we require extra energy. So the energies will be absorbed by this ion. Same thing will be happen here. So here already the electron is present in this isolated gas atom. So if you add one more electron, so these electrons present in the isolated gas atom will repel. So don't come too near to me. So what happens? So but they will attract. But again, this small force or repulsive force, they will repel this electron. So on repelling, some energy is wasted. So that's why overall energy for this energy will be your endothermic. Here also endothermic, but in this case no repulsion there. That's why energy will be exothermic. So always first so electron as a gain enthalpy of the this one is negative, and rest of the two gain enthalpy will be positive. So we can see here the oxygen, if you add electron it become negative, so first energy will be negative, but if you add one more electron to O negative, it become O2 negative, so this will be positive. Similarly sulfur, when you give one electron it become negative, so when you add one more electron it will be not negative, it will be positive. So this is the basic meaning of the electron gain enthalpy of the first one will be always negative and second will be your positive. Now electron affinity. So what is electron affinity? So it is defined as the energy released with when an electron is added to valence shell of the atom in gaseous state. So we are adding electron to the valence shell atom, or that atom should be in gaseous state. So on adding energy, if energy is negative or positive, that depends. So if you add one electron to the first neutral gas as a neutral isolated gaseous atom, the energy will be negative. But if you add any negative anion or 2 minus 3 minus, the energy will be always positive, because that positive energy is due to the absorption of this by the ion due to the repulsive forces of the electron that we have seen previously. Now this energy is measured in electron volt per atom, the kilojoule per mole, kilocalorie per mole. This we have seen previously also during the ionization energy, and it is endothermic for noble gases and alkali earth metal. Why this is endothermic? This is very clear, because so if you give energy to noble gases, already their octet is full, and if you give electron to alkali earth metals, okay, so here what happens, they will absorb some energy due to repulsive forces. So in this case it will be always positive. So this you learn it. Now what are the factors affecting the electron affinity value. So we will see why some energy positive, why some energy negative. So what are the basically regions? So first is effective nuclear charge. Effective nuclear charge means Z by E ratio. So it means this is Z is your atomic number of the nucleus, that is protons, and this is electrons. So Z by E. If there is a more number of protons, less number of electrons, so more effective charges. If there is more number of electrons, less number of protons, there will be less electric charges. So here it is proportional to electron affinity, effective charge. So more effective charge is more attraction of electrons towards nucleus. It is proportional. So it is generally halogens, they have more Z effective charges, so their electron affinity is high, followed by oxygen, then carbon, boron, lithium, nitrogen, beryllium. This I have given some orders. And then chlorine is more having more electron affinity than sulfur, than silicon, phosphorus. So in general this is happening. Actually, if you go left to right, means of the periodic table, so what happens? So in first electron gain enthalpy will be negative. So first electron affinity will be negative. Why? Because size is decreasing. Size is decreasing, like carbon, nitrogen, size decreasing. So what happens? Electron affinity will be so decreasing, and increasing nuclear charge will increase. If size will decrease, that was charge will automatically increase because atomic number is increasing. So here what happens? First will be your first electron affinity will be your negative. This is the one case of the depending of the nuclear charge over electron affinity. Second is the size of the atom. So in size of atoms, if the size of the atom is small, so what happens? Stronger force of attraction for the array electron towards the nucleus. So again what happens? Electron affinity will increase. Second, ellipticity of the subcell. Ellipticity means SP and DF. That is called so more closed subcell, EZ is the addition of electron in that cell. If the subcell is closer to the nucleus, so there addition of electron will be very easy. So S is very close, P is very close, D is very close, F is very close. So here will be easy to add electron. Here is the easy, but here it will be difficult to add electron. Why? Because if you add it, it will not be accepted. Okay, but it will be easily accepted. So this is also ellipticity of the subcell is also ellipticity of the subcell is also depend on the electron affinity. Now next is nature of configuration. Configuration means arrangement of the electrons. So if half field configuration more stable. Half field configuration of the atom is more stable. Why half field configuration more stable? So let us take one example. Electron affinity for first affinity for carbon and electron affinity first affinity for nitrogen. So in nitrogen we have 2p3. You can see here in nitrogen we have 2p3. So this is just half field. But if you take electron affinity for carbon, this is not 2p3, it will be your 2p2. So this is not half, it's incomplete. So here what happens? Addition of electron here is favorable, but here addition of electron is not favorable. Okay, because 2p3 here, if you give one more electron, it will accept, but if you give one more electron, already this is stable, so they will not accept electrons, they will repel. So here somewhat it will be negative, it will be positive. Electron affinity will be negative, positive, here will be electron affinity will be negative. Okay. Now second is competitive field subcell have no vacancy for electron to be added. If you take competitive field subcell, means this one novel gases. Okay, so if you give electron to novel gases or any ions, or can I just sodium plus Fn minus F minus, they have competitive field substance. So again for such element, electron affinity will be 0. So novel gases or any positive electron like Na plus or F minus, so their electron affinity will be 0. So you have to keep in mind all small things. Now periodicity. Periodicity means how this property is changing along the period. So in period, if electron affinity increases left to right, why? Because effective nuclear charge increase that we have seen previously. We see here example lithium, beryllium, boron, carbon, they are along the period. So here we can see electron affinity is increasing, but here we see it is 0, this somewhere 0, 0, the increasing, then 7, 0, then 140, then 3. So somewhat it is increasing, here it is less. Okay, so this depends on the size also. So here it is okay, but why it is 0? Because this is closer to nucleus, and also this is NS2, means if you see the configuration of beryllium, it is NS2 means 2s2 complete cell. So definitely it has very high electron affinity or positive electron affinity. But in case of boron, they have NP1, so this is also incomplete subcell. So energy will somewhat it will be lesser than this one. Also size of the cell is also very small. This is 2p1, this is this is 1s1, this is 2p1. It is I have seen it, ellipticity of subcell, so S is greater than P. So this we have seen it. Okay, so P is away from the nucleus, S is closer to the nucleus. So in S it is easy to add, but here P is difficult to add. Again go for C. So here it is increasing again, and half field subshell. So again this is more stable. So this will give you very less amount of energy. Oxygen again some amount energy. Fluorine very high amount of energy. And if you take inert, so this is neon, this is inert element. So they will give you positive electron affinity, means they will not accept electron. If you go along the group, so along the group, electron affinity decreases with increasing size increases, then electron affinity also decreases. Along the bit increases. Along the period, electron affinity increases due to effective charge, but here due to increasing size decreases. Why? In P block, there's the EA1 for boron, carbon, nitrogen, oxygen, EA1. So if you take all even for a second period, will be always lesser than the electron affinity of the third period, like aluminum, silicon, phosphorus, sulfur, and chlorine. So this is larger size, this is smaller size. So they have so EA1 for this one is lesser, EA1 for this is higher. Okay. So why it is higher? Why it is higher? Because small size of period 2. So due to this, they have high electron density. So they have high electron density. Then what happens? They will repel the test electron. So what is test electron? Means incoming electron. So when this incoming electron come to this element and add it, so first electron affinity will be lesser, and for this one first electron will be higher. So this is the reason. Small size of this electron, due to which they have high electron affinity. So here energy will be less, here energy will be high. Similarly, some questions are given like electron affinity of chlorine. If you take the chlorine in the periodic table, so electron affinity chlorine is always greater than fluorine. Okay, so bromine, iodine. So in halogen group, electron affinity of chlorine is very high. Why? Because if you see this electrons is present in 3p5. We are adding electron 3p5, here we are adding electron 2p. So here 2p is small size, due to small size, what happens? The charge density is increases, and a strong electron repulsion will be there. Actually, what happens? Attraction between the incoming electron or test electron and the nucleus of fluorine atom is considerably counterbalanced. Counterbalanced means, so if you give one electron to this fluorine added, so they will not accept it because of they will not easily accept it because of repulsive forces done by the valence electron of the 2p subshell. So these electrons of the valence electrons of the 2p subshell will repel the test electron or incoming electron. So this what happens? Some of the energy will be counterbalanced or utilized to overcoming those energies. So due to which here some energy is lesser. So energy electron affinity for Cl will be higher. In this way, this becomes higher. So here electron, if you add 3p, it will be easily accepted. So they will give you some energy. But if you do same thing with the fluorine, they will not accept it. So electron affinity of chlorine is highest along the periodic table, and then fluorine, then bromine, and iodine. Similarly, you can see here. So electron affinity for fluorine is greater than Cl minus. Why? Because this is getting inert gas configuration. Second electron affinity for O minus is positive, O is negative. That we know very well. This is endothermic, this is exothermic. Here F is greater than F minus because this is complete configuration, this is incomplete configuration. So second electron affinity will be 0, but here first electron will be higher. So these are the some questions which can be asked in the examination. So write the answer properly.